Alright, so we're going to go over questions 21 to 40 now. So for 21, just move this. Okay, so what we're going to do here, it gives us the measurement of arc BE, which is 84 degrees, and DF, which is 22 degrees, and we want to know what this angle right here is. So the trick, whenever you have some circle, you have this like major arc A, minor arc B, and you want to know what theta is, it's just going to be the difference between the arcs divided by 2. Right? So applying this, our angle is going to be 84 over, or 84 minus 22 over 2, which is going to end up being 31 degrees. So answer choice C is correct. Alright, so moving on, question 22. So still dealing with this same figure. You have that the length of this whole segment, CB, is 22. BD is 5, so that means CD is 7, right? And EF is 7. And so we want to know what CF is. Okay, so here's another formula that you've got to know. So if you've got these two secants passing through the circle that originate from the same point, say AB and XY are the lengths of these respective parts. The formula goes, if you have A times A plus B, that will be equal to X times X plus Y. So you could think of it as the length of the outside segment times the whole is equal to the length of the outside segment times the whole. So applying it to this problem, we get 7 times 7 plus 5 equals X times X plus 7. And so this comes out to 84 equals X squared plus 7X. So we can plug this into our calculator to end solve on the Nspire, and solving for X yields X equals 6.3. So answer choice B is our answer. Alright, so moving on. Okay, so this is a question that I've seen a lot this year, so it's an important one to know. It's kind of like a new question. I haven't seen it a lot in previous years. So there's a formula to know with this one. So it has to do with the angle of rotation of a conic section. So the thing to know is that conic sections are defined by the following equation. So this is ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And so the formula to know is that the cotangent of 2 theta is equal to c minus a over b, I think. Okay, I might have the variables wrong. I'm a bit rusty on this one. So let me just test this out real quick. So that would be this. Okay, I might have had it backwards, y'all. Okay, yeah, I had it backwards. My bad. So it should be a minus c over b. All right. Okay, boxed in, this is the equation you gotta know. All right, so plugging this in to get our angle theta, which is our angle of rotation, we're going to do 1/2 times the inverse cotangent of 3 minus 2 over -7. So like this. So that's going to be 0.5 times the inverse cotangent of, that's going to be -1/7. Comes out to an angle of 49.1 degrees. So that will be answer choice B. All right, so make sure you know this formula. And make sure that whenever it gives you your equation of the conic, that it's equal to 0. I mean, I don't think it should actually affect the formula, but just make sure like everything looks right. Of course, it's only the A, B, and C coefficients that matter at the end. And this one's also sort of a newer kind of question. So, whenever you're dealing in 24 with Aphelion and Perihelion, I believe that's how it's pronounced, you want to find the eccentricity of the orbit. So the eccentricity is going to be, I'm going to just call this A and P. It's like A minus absolute value of A minus P over A plus B. That's it. And so, if we take these values, so take this times 10 to the 4th minus this value times 10 to the 4th over, again, these same numbers, but you're going to sum it at the bottom. Take the absolute value of that. So typing this out, we end up with an eccentricity of 0.0254. And so that will be answer choice A. So again, make sure that you know this formula. Super useful. So moving on to question 25. So we're, I believe that's the end of the geometry questions, or streak of geometry questions. So now we got this algebra question. So we want to subtract these two fractions with these polynomials to get this bigger one, and then take the sum of these over the sum of these. All right. So a trick you can do here is, well, I want you to imagine that we've got 1 as our x. If we were to plug in 1 as our x for this final fraction, we would end up with what we want, which is just the a plus b plus c over d plus e plus f plus g plus h. And so, recognizing that fact, we don't actually have to do any like complex multiplication between polynomials. All we can do is just, what we can do is we can plug in 1 for our x, and so we'd just be doing 2 over 12 minus, would be -2 over, it's 1 minus 4, -3 minus 12, -15. And so that comes out to value of 1 over 30, which is our answer. Now, a variation of this that you might see is if it's asking for like a minus b plus c over uh, d minus e plus f minus g plus h. The thing to recognize here is that if you were to plug in x equals -1 into this expression, you'd end up with this output. So if you're, instead of asking for this, it's asking for this, you'd plug in -1 to get the answer. Yeah, it's a cool little time saver of a trick. So no complex multiplication there. All right, so number 26. So we want to consider the conic section given by this equation. And the foci of the graph are at these 2 points. We want to evaluate b over c. Okay, it's a number less than 1. So the way I typically do this, and it's kind of hard to show on my device because I don't have the Nspire app downloaded, but typically I would graph this onto the graphs page. So after typing this out, as a relation, of course, we'd get a graph, looks somewhat like this. It's a really horrible oval drawing, but after that, I would go menu 6, 9, 3 for foci. I would click on the graph, and I would get my 2 foci points, which are going to be 2 comma negative 0.174 and 2 comma negative 3.83. And so if I were to divide these two y values, I would get a number that's about 0.046. And so that's going to be our answer. Answer choice B. So of course you could do like the eccentricity formula, but I typically like to just do the graphs page because it's faster. You know, half the competition is going as fast as you can to answer as many problems as you can. But moving on to question 27. Okay, so this question's a sinusoidal question. So we have the temperature on an average day in July can vary from this low of 42 degrees at 3 a.m. to 81 degrees at 3 p.m. And we want to know the expected temperature at 11:3 a.m. All right. So you can do a sinusoidal regression on your Nspire, or I guess just to show it, this is actually typically the method that I use, but I think it's a bit slow, so I might change it. I'm pretty comfortable with using this method. Just like how we have vertex form of a parabola. So it looks like that. And we have these values that describe our squish or stretch with the A, our horizontal displacement with the H, and our vertical displacement with the K. For sinusoidal equations, we would have something like, I write it as A times sine of 2 pi over b times x minus h plus k. And so h and k are the same. They're the horizontal translation and the vertical translation. A is the amplitude. So typically a sine curve looks like this. Or I guess to make it a little bit more extreme. So amplitude is from like the middle to one of the peaks or one of the troughs. And so that's what our A represents. And our B represents how long it takes to complete a full cycle. So this would be one full cycle. Okay, so typically, like in these problems, when we're dealing with 24 hours, like something cycling every 24 hours, our B, I'm going to start constructing this equation. Our B is typically 24. So I'll write that. X right here. And it doesn't really matter what you put for the H, because you could get the answer either way. But if you want to be specific, knowing that the sine function, it doesn't have a peak until what would be 6 on our graph, because it goes like 6, 12, 18, and 24 is back to one full cycle. So like that. Oh, and by the way, for our A, I might as well do this because it's pretty quick. So the A is going to be the difference between our peak and trough divided by 2, right? And so that's going to be a value of, I believe, 39 over 2, right? And so now that we got that, we can also establish our vertical translation. It's going to be that value minus, it's going to be 81 minus that distance, or that amplitude. So then we'll have it as, how can I write that? That'd be like 81 is like this over 2 minus 39 over 2. I guess we could say 83 over 2. So plus 83 over 2. Or is that right? No. No, wait, no, I think that's right. Yeah, I think that's right. Actually, no. What am I doing? I can't subtract, guys. Okay, so 123 over 2. Yikes. Okay. So now that we've got that established, given that our peak is going to be at 3 p.m. instead of 6, I might want to translate the graph 3 units to the left to account for that. So I'd be subtracting by negative 3. So then I could write this as x plus 3. So then everything here shifts to make it such that this peaks at like 3, and our trough would be at like, and that's considering, that makes our origin 12 p.m. So keep that in mind. And so this becomes our equation, right? And so if we were to want to get the value at 11:30 a.m., that'd be equivalent to getting the value at x equals negative 1/2, right? Because it's going to be like half an hour before 12 p.m., which is the origin. So making sure you're in radians, of course, we're going to do 39 over 2 times sine of 2 pi over 24 times negative 0.5 plus 3 plus 123 over 2. And so plugging in, so that's f of negative 1/2, we get 73.4 degrees. that's going to be answer choice B. Oh, and that's our answer. So the thing to know is just how to construct a sinusoidal equation like this. But moving on, so we get to question 28. So we've got this expression. We've got sine of 2 theta over 2 minus 2 times sine of theta squared. All right. So one thing you could do is you can guess and check. You can like set theta to like 3, plug it in here, and then check all the answer choices. Or you can work it out using trig identities. So the two trig identities you want to know are the double angle identity for sine of 2 theta, which is 2 times cos theta times sine theta, and the Pythagorean identity, which states that sine squared theta plus cos squared theta equals 1. So if we take this expression, so that's sine of 2 theta over 2 minus 2 times sine squared theta, I can rewrite this as 2 times cos theta times sine theta over, and I can factor a 2 from the bottom. That'll be 1 minus sine squared theta. So knowing this identity, we can get that that bottom part in the parentheses should just be equal to cos squared theta. And so now we can start canceling out things. We can cancel out this 2 and this 2. And we can cancel out this cos on the top with one of the coses on the bottom, leaving us with sine theta over cos theta. And we know sine over cosine, that's tangent. So C, answer choice C, of tangent of theta is our answer. So make sure you know the angle identities, important trig identities. But of course, if you don't know it, you can always guess and check. Just plug a number in for theta and test all of these 5 answer choices. All right, but moving on to the next question. So that'll be question 29. We want to find the sum of the following sequence. So we call this sequence a Fibonacci-like sequence. We call it that because it's not exactly the Fibonacci sequence, but it follows this pattern of you add the last 2 digits, or last 2 numbers in the sequence to get the next one, and then the last 2 to get the next one, and so on and so on. So the formula, so to get the sum of the Fibonacci-like sequence, so the sum of the Fibonacci-like sequences from like, I don't know, we could say like I equals 1 to I equals n. That's going to be equal to f of n plus 2 minus f of 2. Okay? So what that means is we've got to find the next Fibonacci number. So we got to go 2 ahead. And so if we add these last 2 numbers that we have right now, that will get us the next one, which is 2707. Then we add the next one, or we add these 2 to get the next one, and that'll be 4380. So we're going to do 4380 minus f of 2, which is the second Fibonacci number. So that's going to be 23. And so that gets us 4357. So that's going to be answer choice D. So make sure, if you want to find the sum of a Fibonacci-like sequence, remember this formula. It's also pretty useful for the number sense competition if you see a series like that. Alright, so now moving on to question 30. Terry is building a bookshelf pictured to the right for his study. The overall dimensions are 4 feet wide, 7 feet tall, 3 feet deep. And so I'm building 6 shelves, including the bottom shelf. The shelf on the back of the bookshelf is going to be, or the front and back of the bookshelf are going to be open. And we're given the thickness of the wood. So we want to know like the total number of, or total volume that's going to be used. Alright, so this is actually not too bad of a question. So you just gotta keep track of how everything's gonna look. So I'm gonna draw 2 images here. So this is like a little like miniature shelf. I won't draw the whole thing, but I might create these yellow lines, like these dashed lines here. These are gonna be running all the way back. So really what this shelf is, it's these 2 big magenta pieces, I'm coloring them as, which have a length, width, and height of 3, a width of 5/8 of an inch, so 3/8 or 5/8 5/8 of an inch, so 5/8 over 12, like that many feet, and a height of 7. So we have 2 of those, and then these middle pieces, which I'm going to color orange, it's going to be 1. I'll actually go to this drawing. It's going to be like 1, 2, 3, 4, 5, 6, 7 of them. And these pieces, so these are going to have a length, width, and height of, so it's going to be 4 minus, because again, this whole thing is 4, but the thickness of the wood here is 5/8 of an inch. So that's 5/8 over 12 here, and 5/8 over 12 here. So it's like 4 minus 2 times 5/8 over 12. So it's that many feet. The width is going to be 3. And the height is going to be, well, 5/8 over 12. Right, it's going to have like a little height like that. And so again, we're going to have a total of 7 of those. And for those 2 magenta plates, we're going to have 2. Misspoke. And so we're just going to do 7 times the length, width, and height, which is 4 minus 2 times 5 over 8 over 12, times 3 times 5 over 8 over 12. We're going to add that with those 2 magenta plates. So we're going to add 2 times 3 times 5 over 8 over 12 times 7. And so we get an answer of about 6.448, so 6.45. That'll be answer choice E, which is the correct answer. This one you just want to make sure you're being very mindful of that thickness of the wood. So that's a nice fun little geometry question. Then we have 31. So we want to consider the cubic with the function, well, this is just a standard cubic. It has roots p, q, and r. So we want to know what the value of p plus q plus r, that's the sum of the roots, and pq plus pr plus qr, which is the sum of the product of the roots taken two at a time. And so it's very important to know Vieta's formulas. So for a cubic, the sum of the roots is equal to negative b over a. The sum of the product of the roots taken two at a time is c over a. And the product of the roots is negative d over a. So we're going to be only using these two. So we wanted to get the sum of the roots, so that's going to be negative b over a, plus the sum of the roots taken two at a time, so that's going to be plus c over a. Well, we combine these fractions, we're going to get c minus b over a, and so that will be answer choice E. So just make sure you know Vieta's formulas for these kind of questions. They're useful in like a bunch of other algebraic questions as well. Alright, so moving on to 32. Matt is riding his bike around the block, and so we've got these 5 speeds. We want to know what his average speed is. Okay, so this is a trick question. So your first thought might be to get the average of the speeds by just adding them up and dividing by 5. But what you really want to do for this kind of question is you want to take the harmonic mean. I'll take the harmonic mean of the speeds. So this is only when you're dealing with like speeds is that you have to take the harmonic mean. In most other cases for other quantities, like if you're trying to get the average grade on a test or the average weight of a person, usually just do the arithmetic mean. But when you're dealing with speeds, you have to do harmonic mean. And so that's going to be, to take the harmonic mean, it's the number of things over 1 over like the first thing plus 1 over the second thing, all the way to like, you have like your last thing. So it's just the number of things over the sums of the reciprocals of your things. So we have 5 things, 5 speeds. Then we're going to add 1 over the first speed plus 1 over the second speed plus 1 over the third speed, and of course so on till we add our last speed. And so we're going to take this value, I'm going to calculate this expression. So after typing this out, we get a value of 14.56, 14.16. Just going to be answer choice B. So make sure when you're trying to get the average speed, of something, you've got to take the harmonic mean. Okay, so question 33. Hank is a chihuahua, and he's watching a squirrel climb a tree. Might as well draw it. Got like a tree thing. So let's call this black dot the squirrel, and uh, this black dot here, the chihuahua. And so the squirrel is climbing at a constant rate of 4 inches per second. When it first spots the squirrel, it's at an angle of elevation of 30 degrees. So like that. And then later, so I'm just going to draw the tree again down here. So the squirrel's going to move up. And I think it tells us how much later. 20 seconds later, turns to an angle of elevation of 62 degrees. And this is 20 seconds later. And of course, this is not drawn to scale by any means. This is not a 62-degree angle. But nevertheless, we want to know how far from the base of the tree the chihuahua is. So we want to know this distance x. So here's what we can do. Let's call this distance x. So the squirrel's original height would be this length, which would be x times the tangent of 30 degrees. And so after the 20 seconds, we've got that initial value of x times the tangent of 30 degrees. But again, it's 20 seconds later, and the squirrel climbs at a rate of 4 inches per second, right? So 4 inches per second. So that means that the squirrel gained the height of this initial value plus 20 times 4. Of course, inches per second. All of our answer choices are in feet, so I'm just going to divide this by 12. So it's going to be 12 times 4 over, 20 times 4 over 12 feet that were gained in the course of those 20 seconds. All right. Though keep in mind, this distance is still x. Now we can also represent the same height as x times the tangent of 62 degrees. And so we've got two equivalent expressions. We've got x times the tangent of 30 degrees plus 20 times 4 over 12 is equal to x times the tangent of 62 degrees. So, of course, making sure you're in degrees, we can type this expression into our solver. So after typing this equation into nsolve, we get a value of x that is 5.1 feet. So that's answer choice A. So that's the correct answer. So we just had to compare those two equations. All right, so moving on to question 34. Okay, so Jason has decided to he's decided to solve this equation by completing the square. On his third step, he has decided he must add blank to both sides of the equation. Okay, so you just gotta know how to complete the square. So first thing is you make sure the a term is 1. So we're going to divide everything by 2. Second step, we want to move the negative 8 to the other side. So then it's going to become x squared minus 4x equals 8. And the third step is we're going to add to both sides. We want to add b over 2 squared to both sides. So in this case, our b is negative 4. And then we're going to divide by 2 and square. And so we're going to add that to both sides of the expression. This way we get a perfect square trinomial on this side. So this is x minus 2 squared equals 12. And so that becomes useful for solving some quadratics. But again, what we want to know in this question is what number are we adding to both sides? And so this number right here is 4. And so to both sides of the equation, we're just going to add the number 4. So this one you just have to know how to complete the square. That one's not too bad. So moving on, we have question 35. So for 35, we have the point A, which is b comma 8, lies on the graph of the parametric equations. This one and this one, we want to know what the value of b is. Okay, so the thing to know is that for parametric equations, typically for most equations, you define y as a function of x. Like, x is the independent or y is the dependent. With parametrics, both x and y are dependent. They depend on t, which is time. And so what we can do is, given these two equations, and I'll write them up here. As you can see, they're both dependent on time. Well, we've got our y-coordinate, so what we can do is we can work backwards from our y-coordinate to get our time t, and then take that value, plug it into the x equation to get our x-coordinate. Okay, so we have 8 equals log 2 of t plus 1. So we'll raise both sides to the power of 2. This goes away. We get 256 equals t plus 1. Therefore, 255 equals t. And then we're going to plug that into our x. So we're going to do x of 255, which is going to be 255 squared minus 50 times 255. And so typing that into our equation, we're going to get 52,275. And to the nearest hundred, it's going to be 52,300. So that'll be answer choice B. So to solve this parametric equation, all we had to do was, using our y, get our value of t, and plug that into our x equation to get our value of x. Okay, so moving on to the next question, question 36. The first two terms of a geometric sequence, so that's a keyword, are 200 and 80, respectively. We want to know what the sum of the infinite sequence is. So a geometric sequence, So an arithmetic sequence, for example, is you're adding by the same rate over time. So like there's equal spacing. But with geometric, you're multiplying by the same rate over time. In this case, that would be 2/5. And so the next term would be 32. And so on. So to get the sum of an infinite geometric sequence, the sum of infinite geosequence, it's going to be the initial value, which is a naught, over 1 minus r, which is your rate. And so, plugging this scenario into this formula, our first term is 200. We're going to divide it by 1 minus r. And so that's our rate of 2/5, which you can get by doing this term divided by this term. And so that's going to be 200 over 3/5. So that's going to be 1,000 over 3, which is going to be 333 1/3. So that's our answer. So just make sure you know this formula. Sum of an infinite geometric sequence. But moving on to the next question, question 37. Okay, the probability that Aiden, oops, I didn't erase this. Okay, probability that Aiden is able to cut a leaf out of a pattern by following the lines is 0.72. Okay, what's the probability that Aiden is able to cut a leaf out of a pattern exactly 6 times? He's given 10 leaves to attempt cutting out. Alright, so it's just the probability that he does this thing. P of A. That's 0.72. We want to know the probability he's able to cut it exactly 6 times. So here's a question. How many ways can he cut it 6 times? So let's say he has a success. He successfully cuts it 6 times. That means he has to incorrectly cut it 4 times. But is this the only way it can happen? It's not. What if he got the first 5 right, and the next 4 wrong, and then the last one right? That would still be 6 successes and 4 failures. So the number of different possibilities here is actually going to be it's going to be 10 choose 6. So you can type this on your calculator usually. So 10 choose 6. The formula, in case you can't find on your calculator, of A choose B is A factorial over A minus B factorial times B factorial. Where factorial, like for example 4 factorial means 4 times 3 times 2 times 1. 10 factorial means 10 times 9 times 8 times all the integers down to 1. Alright? And so there's 10 times 6, or 10 choose 6, 10 choose 6 ways to arrange this. We're going to multiply this by the probability of him successfully doing that action, raised to the amount of times he successfully does it. That's 0.72, and he's supposed to cut it exactly 6 times, so we're going to raise that to the power of 6. That makes sense. But of course, he's got to fail 4 times. So if we do 1 minus 0.72, that gives us the probability of failure. We raise it to the number of times he failed, which is 4. And so this will get us the exact probability that he successfully cuts it 6 times. And so typing this on the calculator gets me a value of 0.18. So that's our answer. Okay, so 38. Okay, Paul hates mosquitoes more than most. He estimates that there are 250 mosquitoes in his backyard at the beginning of one evening before he turns on his bug zapper. He takes delight in how many mosquitoes get zapped each night. On the same evening, he estimates he has 250 mosquitoes in his backyard at the beginning of the night. He counts 140 zaps have happened 35 minutes after he first turned on his bug zapper. How much more time until there are less than 10 mosquitoes in the backyard? Okay, so you want to model this like an exponential function. So this would be like some initial value a times some rate raised to the some time, right? This initial and this output will get you like the number remaining at time t. And so we know what our initial is. It's 250. We're going to solve for our rate right now. So I'm going to express the time in terms of hours, since that's what our answer choices are described as. So that's 85 minutes, so 85 over 60. That's the time in hours. So after this time, he counted 140 zaps, meaning that 110 bugs remain after this time. And so, if we solve for r, we get that r is equal to 0.56017. Alright, and so we want to know how much more time there will be such that there are less than 10 bugs in this yard. So we're going to set 10 equal to 250 times our rate raised to the power t. We're going to solve for t. And so t comes out to 5.55. But keep in mind that this time represents the time since he started the zapping. But we want to know how much more time it will take after the initial 85 minutes. So we've got to do 5.55 minus 85 over 60 to get our answer. So that's going to come out to about 4.13 or just 4.1. So that leaves answer choice E as our answer. Alright, so moving on to the next question, question 39, geometry one. So a 6-foot piece of string is cut into 3 pieces that will form a circle, equilateral triangle, and a square. The areas of each figure are equal. We want to know what the circumference of the circle will be. Okay, so let's call the area of any of these shapes, so any area of any shape, because they're all the same value, let's set that equal to x. So 6 is going to be equal to the sums of the perimeters of each of these shapes. So, well, for a square, if I have my area and it's x, if I get the square root, I get the side of the square. If I multiply by 4, I get its perimeter. So right here, this is the perimeter of the square. And next, you're going to see I'm going to just get the expressions for the perimeters from the area x. Let's take the circle. So I'm going to divide the area by pi, then get the square root. That'll be my radius. And I've got to multiply this value by 2 pi to get its circumference. So, which is like, its perimeter. So that's the perimeter of the circle. And then lastly, to get the perimeter of the equilateral triangle, got my equilateral triangle formula for the area of it. It's side squared times square root 3 over 4 is the equilateral triangle's area formula. So working backwards to get the side, it's going to be 4 times x over the square root of 3, and take the square root of that. And then I've got to multiply this value by 3. So like this. And so now I've got the perimeter expressions for all of these shapes. I can solve for x, because the sums of these perimeters should equal to the total length of that original string, which was 6 feet. So I can type this equation into my solver. So I get an x that's equal to 0.2457. And of course I want to know what the circumference of the circle is. Also, important thing to know is this is in square feet. Okay, so I want to know what the circumference of the circle is in inches, right? So I'm just going to plug this into this expression, which gets me the circumference of the circle. So that's going to be the square root of 0.2457 over pi times 2 pi. And then I need to multiply that by 12 to turn it from feet to inches. And that gets me a value of 21.1 inches. And so answer choice E is the correct answer. So that's a nice little geometry question, involved a bit of algebra. But moving on to the last question for today's video. Question 40. So Jeff has invested $10,200 in a CD that earns 5.25% interest compounded quarterly. How much interest will Jeff have once the CD's run its course over 3 years? Okay, so you gotta know the compound interest formula. So I'm gonna just say your final money is equal to your initial money times 1 plus your rate over how many times you're compounding it. So we'll represent that by C. Raised to the power of years times how many times you're compounding it. And keep in mind, your interest Okay, so like your initial amount plus your interest is equal to your final amount. So once we get this value, we need to subtract the initial value that you put in, which was the 10,200, to get the interest. So we're going to do 10,200 times 1 plus, and so we want to write our percentage in decimal form, so that's 0.0525. It's compounded quarterly, so that's 4 raised to the power of 3 times 4. And so if we type this out, we get that this is going to come out to $11,927.70. So now we're going to take this final amount we earned, subtract it from our initial, round it to the nearest dollar, and so that's going to come out to $1,728. So that's going to be answer choice B. So make sure you know the compound interest formula right there. Alright, so that concludes part 2 of covering this test. In the next part, we're going to go over a lot of the calculus and statistics concepts covered in the test. So stay tuned. That's it for this video. Hope you all enjoyed, and I'll see you next time.